Hi everyone, hope you are doing okay. I'm just doing fine. It's Reza, and this is our course Summer 2023 Fundamentals of Programming 2 or CPCS 2620. At first, we have a blitz introduction about me and about the whole computer science course and about the course that you passed previously, Funda of Programming 1, and the course in which you this semester registered, Fundamentals of Programming 2. All right, about me, I graduated from Tehran Polytechnic. I finished my bachelor in computer science and then came here. I'm a master's student here and doing research on natural language processing using graph neural networks. And about the whole computer science program, this diagram is pretty much what we are going to do in the whole computer science program. And let me use a pen. All right, this is this person exists in a real world. This person has a problem and he likes to solve the problem by computers because he needs to automate that process because otherwise we can replace the whole diagram from programming up to the end with humans, but we don't want to do that. So first this person has a problem, whatever it is, it doesn't matter, and then once we have a problem, we define the problem, we find the constituent elements of that problem, and then formalize that in a mathematical or in a well-defined language, and then convert it and then use some algorithms if necessary. For instance, let's say we have a problem of reporting a student's grades on Moodle, but we also need to report the students' grades incrementally. So we have a problem, we have a sub problem which is sorting. For sorting, we need an intelligent algorithm. We need a smart algorithm to tackle that. Otherwise, it would take so much time. So here in this problem, we might use some specific algorithms, but yeah, if you have a simple problem, probably you don't need to use any sophisticated algorithm, and you can easily jump into the next section, which is programming. And for programming, we have different options: C++, Python, Java, or any other languages that you know, high-level languages. And then once we have our program written in a file, there are some other tools that help us to communicate this problem to the operating system. Operating system is a software, is a huge software which is communicating with the rest of the diagram that we have, which is a physical computer, physical components of our computer. And operating systems are like Linux, Mac OS, or Windows, or other operating systems that we have, for instance, Android. And also we have virtual machines and other different types of operating systems. All right. And then in this course, we will mainly focus on problems, algorithms, programming languages, particularly C++, and we scratch the surface of operating systems, not too much, just we learn some basic commands to communicate with the operating system and run our program. All right, it was about the computer science program, and I forgot to mention that we have some very useful paradigms, but these are very useful, but paradigms that we are using in computer science are not limited to these three. Abstraction, which means when we have a problem, we try to abstract that and use, for instance, mathematics to represent that. And modularization means we don't tackle the problem all in once. We break that problem down to different parts, and also for solving the problem we have different modules and we chain them together, and once we chain them, it we are using transformation mindset or paradigm. But transformation also does have other meaning in different courses, like in theory of computation we have transformation, reduction, but yeah, it's not in the scope of this video. All right, fundamental of programming 1, or computer science 1620. You remember here in this diagram, when we have our program, we need to communicate and talk with the operating system that we have. But for this communication, we have two different methods, using interpreters or using compilers. We had this discussion in 1620. I don't get into the details right now, but just to review that, we have two different ways, interpreters and compilers. And for compilers, we had different options, like we could use online compilers or on compilers on your local machine. And I also wrote another part because I vividly remembered the first day in my first programming course in my bachelor program, and I was lost, and I tried to wrote down some notes here for the students to go through that experience and get a way around that, which is first try to concentrate on the main concepts. Like in 1620 we had functions, we had data types, and we had arrays, and very simple bash scripting. We had also some introduction to Linux commands, and more important Linux commands. I was suggesting them try to focus and concentrate and learn these main concepts. And next, if you have enough time, and if you see something is interfering with your understanding of the main concepts, and then raise a question, ask your prof, ask your tutor, ask your instructor to have that problem solved. And for some students, they already had a prior knowledge of programming, and those students could go to the third part and ask some advanced CPP questions. And yeah, about fund of programming 2 or 2620, what we already know from previous course. 1620 is basic C++ syntax, like control flows, basic libraries, functions, data types, etc. And we also know some basic algorithms and paradigms. We know how to convert our problem into pseudocode, and then pseudocode into the programming language like C++ code. And we also know how to do procedural programming. We already know some basic concepts, but in this course we will learn advanced syntax like class, or advanced data types like vector, stack, queue, BSD, and balanced BSD. And we also will learn about templates or overloading or other advanced topics. And next we also have advanced algorithms and paradigms like searching and sorting. Searching and sortings are the most important subroutines in almost all the problems that we have in computer science, and they are very important. And next we have object-oriented programming. This is a paradigm, and Next, we need to know how to structure our C++ project into header files, and we separate the main file into different uh, core different files that they have high cohesion and high um, they have high cohesion. And next, how to prioritize things here in 2620. First, try to learn the main algorithms, paradigms, and syntax that we will they will be covered through lectures. And if you have enough time, if you have already done the first step perfectly, if all the assignments are aced, and then you can go to the next part, which is highly suggested. uh, you remember we had different parts here. I would suggest you to at least build a curiosity about the how other layers are working and how they are providing service to other layers, and um, read about them. And this would be a gentle introduction for you for your other courses in the other semesters as well. So yeah, you have this. The next priority that I would say I would suggest is learning about other layers, at least some introduction and some learnings at some surface level. And yeah, it's the second thing that I would suggest. And there are two notes. C++ is huge. There is no end to the C++ syntax, and there are many different things. And don't get lost into the minutia. You you don't need so much details about the C++ syntax. Once you know the main concepts and you know how to search about your need, you can find the proper advanced C++ syntax later on. So for now, for this course, just stick to the lectures and what it is taught, and don't go so much beyond what will be covered during this course. And the next thing is you need a scripting language like Python. In especially at this university, you only learn C++, but I would highly suggest that once you pass this course with a great score, you jump into Python and learn a scripting language. And that's pretty much it. Thank you.